Welcome to our presentation. Today we are going to talk about one of the fundamental concept in object-oriented programming, that is access specifier in Java. This concept is crucial for structuring code in a modular and reusable way, and understanding it is key to mastering in Java. Over the next few minutes, we will be covering various aspects of access specifier, from its definition and syntax to its practical applications and the benefits it brings to Java development. Let me introduce my team. Presenting with me today are Sakshi and Sanika. Together, we will guide you through the topic step by step, starting with the basics and gradually moving into more advanced features of access specifier. So, let's begin by understanding what access specifier is and why it's so important in Java. Before we dive into the details of access specifier, let a quick look at today's agenda. First, we will introduce the concept of access specifier in Java and explore its importance in object-oriented programming. Next, we will discuss the types of access specifier that Java support along with the ones it doesn't. Finally, we will go over the advantages and disadvantages of access specifier, followed by a quick conclusion. Each of these topics we will help you understand how access specifier work and how it can be effectively used in Java programming. Let's get started. Let's start today's topic with the introduction. In the dynamic landscape of Java programming, mastering access specifiers is essential for crafting robust, maintainable, and secure code. These specifiers, namely public, private, protected, and default, define the visibility and accessibility of classes, methods, and variables within a Java program. In this extensive guide, we will deeper into the intricacies of each access specifier, breaking down their significance and providing real world insights through a concise and relevant Java code example. We aim to empower developers with a comprehensive understanding, enabling them to make informed decisions about their code structure.
Slide. Here we are understanding types of access specifiers. There are mainly three types of access specifiers: public access specifier, private access specifier, and protected access specifiers. Now let's go for public access specifiers. The public access specifier is based on unrestricted access to the class, method, or variable. It can be accessed from any other class or package. The visibility is expansive, making it a powerful tool when broad accessibility is required. Public class, variable, and method allows external classes to access and utilize them freely. Next, we have private access specifier. Conversely, the private access specifier imposes restrictions confining access to only within the same class. This provides encapsulation, preventing direct access from outside classes. This encapsulation shields these elements from the external interfaces. Now, third one is protected access specifier. The protected access specifier allows access within the same package or by subclass even if they are different packages. This provides a middle ground between public and private access, balancing accessibility and encapsulation. Then next we have a default package private access specifier. When no access specifier is specified, is also known as package private or default access. The scope is limited to the package. It strikes a balance between encapsulation and visibility within the package. In this case, limits access Default access specifier class limits access to its elements to classes within the same package, promoting encapsulation within a defined scope.
For the narrower scope that provides the necessary visibility without exposing more than required. This helps in maintaining a clean and secure code base. Second, encapsulation matters. Leverage the power of private access for variables and methods that should not be directly accessed from outside the class. Encapsulation is fundamental principle for building robust and modular code. Third, consider the package. While default access is package private, be mindful of the package structure. If if a class or method should only be accessible within the same package, default access is suitable choice for balancing accessibility and security. Understanding the trade-offs between different access specifier is essential. Striking a balance between accessibility and security ensures that code is both functional and well protected. Real world application access specifier in banking system consider a banking system where the classes customer and bank account interact. The customer classes may have a private method for validating customer details, while the bank account class exposes the public method for balance inquiry. The design ensures the encapsulation of sensitive information. Customer.java public class customer, private boolean validate customer details, validation logic return to true bank account.java public class bank account public in check balance in bracket customer if in brackets customer dot validate customer details logic for checking balance return 1000 explain balance else return 1 validation failed. In the real world scenario, access specifier employed judiciously to encapsulate the validation logic within the customer class, safe, safeguarding it from external manipulation. The bank account class, in contrast, exposes a public method for checking the balance, providing controlled access to relevant information. Advanced concept nested class and access specifier in Java nested classes introduce an additional layer of encapsulation and access specifier play a crucial role in defining the visibility of these nested classes. Consider the following example. Outer class Java, a public class outer class, private outer private variable is equal to 42. Protected class inner class void display outer variable bracket system.println in bracket outer variable plus outer private variable. Here the here the inner class is protected, allowing it to access by subclasses or within the same package. This example showcases how access specifiers extend their influence even nested classes, emphasizing the importance of maintaining a coherent encapsulation strategy. Handling access specifier across inheritance. Inheritance is a hierarchical relationship between class and class access specifier govern how members of parent class inherit by subclass. Consider the following example. Parent class dot Java, public class parent class. Private in private variable is equal to 42. Protected variable void method bracket system dot out dot println in brackets protected method call.